My name is Debra Emanuel, and I'm head of marketing at Repair. Repair is a direct air capture company, and we remove excess CO2 from the atmosphere. Carbon emissions have not been reduced to the targets that have been set. In order to mitigate the effects of climate change, we must do more than reduce our emissions. We must implement direct air capture. This is the only way we're going to reduce and remove historical and hard-to-abate emissions. To reach net zero by 2050, we must remove 10 billion tons of carbon a year. Okay. But the problem is that conventional direct air capture solutions are not economically viable at scale. They're way too energy intensive, with more than 2 megawatts per ton, and they're way too expensive, with a projected levelized cost of over $200 per ton. This is where Repair comes in. Repair's direct air capture solution outperforms other direct air capture solutions with the lowest energy consumption, the lowest cost, and the fastest time to scale up. Repair's solution consumes only 600 kilowatts per ton, which is much less than the industry standard of 2 megawatts per ton. Repair also has the lowest projected levelized cost at scale, with only $50 a ton, which is much less than the industry standard of $200 a ton. Before I get to the third point, I'd like to go over the technology benefits. So Repair's solution is based on an electrochemical process. It's fully electric with zero heat. There are no liquids, no solvents, no hazardous materials, and no waste. And this allows us to scale up quickly because we don't have the pools of chemicals that other solutions have to deal with. This also means that it's safe for people and the environment. So this brings me to our third point, the fastest time to scale up. It all starts with one electrochemical cell, which is stacked into what we call our stack-stack module. Carbon capture capacity is reached by stacking of cells, by stacking of modules, by stacking of rows of modules, until we get to the plant-size scale. And this simplistic, unique design is ideal for mass manufacturing and easy deployment. So we started with one technology, and now we have two solutions, and we're rapidly scaling up. We recently launched a field prototype, and we were able to reach TRL6, and we took this unique direct air capture technology, and we applied it to a diluted point source application of 1%. And for the automotive industry, aluminum is very, very important. It's really important also for the energy transition. But the problem is the emissions. It produces over 270 million tons of CO2 a year with no viable solution. So we have two pilots with two global aluminum manufacturers. And we're expanding our commercial growth globally. We have DAC hubs in the US, and we recently launched a direct air capture and storage agreement with Sela in Kenya. Recently also, as of last week, we recently just signed a direct air capture and storage partnership with Enerth, which is a subsidiary of Energean. This Prinos CO2 project, when fully developed by 2028, will be able to store 3 million tons of CO2 a year. We've raised $12 million, received $2 million in grants. We have 5 patents and 25 employees. With the lowest energy consumption, the lowest cost, and the fastest time to scale, we're uniquely positioned to reach the megaton scale at 2030, and we invite you to join us for our ride. Thank you very much.
Hi, Jared.
Hi.
From DOE again.
Hi, Jared.
Just curious who your main competitors are and kind of where would you say is the one point that differentiates you from them?
Okay, so I mentioned it about the solvents and the pools and things like that. So we are virtually dry. So our system, our solution basically only needs humidified air. Our main competitors are Mission Zero, recently came out, Carbon Atlantis. They both work like on an electrochemical process. So hope that answers your question.
Thank you.
Okay.